Hello everyone and welcome back to the Core of Everything with Jack and Mark and our conversation with Jonah McLeod all about rivers. We're also sponsored by absolutely no one. So if anyone's interested, please get in touch at either Instagram or Twitter. So we talked about the types of rivers, but I think we could talk about a little bit more about why rivers are actually important to society. Obviously we alluded to earlier on that it was bedrock for a lot of ancient civilizations. I think the Mesopotamia, what was it? Well, how do you pronounce
Mesopotamia.
Mesopotamia, that's it.
Yeah, say it again, Jack.
Billiard ball.
You got that right.
Did I?
Yeah.
Amazing. So yeah, right, why are rivers important? So obviously we know that they are a highway for a lot of trade, and we know that the areas surrounding rivers are very fertile. So there's a lot of farmland and great for irrigation and such.
Yeah, well, I mean, there's loads of examples of some of the earliest big civilizations across the planet springing up where you have these huge, important rivers with large floodplains. So the floodplain is, well, it sort of does what it says on the tin. If you have a river and a large, flat landscape either side, when this river floods, that whole area gets inundated with water and with fine sediment, and that makes these floodplains really good for growing plants and for doing agriculture. And this was completely vital for early civilizations like the Tigris River in Mesopotamia, as you correctly pronounced earlier. The Nile, as you've also talked about already. Rivers are the backbones of empires. The Yellow River in China as well. And so not only do they have a real quantifiable benefit for communities and civilizations all the way back into the past, but they've also developed, due to this really long, rich history of rivers being at the center of civilizations, they've developed a really important spiritual role across the world.
If you think about like cities, like so many of them, like, you've got the Thames, the Loire, the Rhine, the Tyne, all the big cities are built. Are all cities built on rivers? Can't really imagine.
Well, not all cities are built on rivers, but all of the major European capital cities, except Madrid for some reason, are built on big rivers.
Interesting. I wonder what the thinking was behind Madrid.
Was it one of those cities where they just wanted to put it at the very centre of the nation for some reason, like they did with Brasilia, I think?
Oh, right.
Where they made it the capital because it was in the middle. Maybe that was a Madrid situation as well. I'm not sure.
Yeah.
I don't know, if people are going from, say, the south to the north, and north to the south, and east to the west, like that sort of thing, across the country, they're very cross-cutting a central point, as they thought, I might as well build Madrid here.
Yeah.
I have a feeling. No, I went to like the History of Madrid Museum in Madrid, so I should know this. I have a feeling it's on high ground, therefore a river is unlikely to flow through it, but strategically.
Yeah.
You might be benefited by being on a hill.
Yeah.
Might be something about that.
So next week on The Core of Everything, we will have someone talking about hills.
Specifically around Madrid.
In the central Spain
We'll find
area.
an expert on hills in Madrid.
And there are so many other reasons why rivers are really important as well. Historically, culturally, they're super significant. But talking geomorphically, as I kind of already have, rivers are the single most significant transporter of water and sediment, of material, across the Earth's continents. So,
Really?
Yeah, the biggest way in which natural material gets from A to B. The majority of erosion and deposition on the continents is due to rivers. And rivers and fluvial processes really do decide what landscapes look like.
I guess the Grand Canyon is testament to that.
Some of the most dramatic landscapes on Earth are all down to fluvial incision.
And not just on Earth, right?
Yeah.
Here we go, launching ourselves into space one more time.
Nice segue.
But like Mars, we think that we found evidence for rivers and kind of these fluvial systems, right?
There's really clear evidence. You can see from space gigantic river channels, river gullies that you can trace back to craters. So the idea being that you may have had a sort of a crater lake formed by an impact crater. Go back and listen to last week's episode featuring Benusha. That may have held a sort of crater lake, or maybe a glacier or anything like that, that has melted. It's burst the rim of this crater, and it's all flowed out in one, what they call megaflood.
Wow.
With an extraordinary erosive capability, with erosive power, and it's carved out these gigantic channels that go hundreds of kilometres across the surface of
That's
Mars.
so cool. You can see that from space as well.
That is absolutely astonishing. These idea of megafloods, their powers are extreme. I think the English Channel was formed via a megaflood. I was reading this book Origins, and I came across this chapter talking about the English Channel and how essentially in the few ice ages ago, I'd imagine, obviously the North Sea was sort of frozen. It was all frozen over up there, and then what happened was it formed this massive ice wall in the North Sea, and essentially what happened, as it started to melt, water started to gather behind this ice wall. I should point out as well that France and England at this point was joined. It had like a land bridge. But essentially behind this ice wall, this ice started to melt and started to gather water. And as the water filled up behind the ice wall, it started to overflow and forming these big, gigantic waterfalls. And as waterfalls they do, they erode. As they hit the sort of the plunge pool at the base of the ice wall, it started to erode the ice from beneath. And over time, the ice wall collapsed and formed this massive flood that headed towards this land bridge between England and France.
Wow.
And had this incredible erosive capacity that smashed the land bridge out of the way. And we can see the evidence for this as these scars at the bottom of the English Channel. And that's how the English Channel formed, is generally this mega flood. Anyway, I was explaining this concept after reading this. I couldn't believe how wonderful this concept was. And I was explaining this at dinner. And turns out that one of the people at the dinner was the person that discovered it. It was Jenny Collier.
It was Jenny Collier and Sanjeev Gupta, wasn't it?
Exactly.
That did this
both at
project
Imperial
together.
College.
Didn't this happen before to you? For some, you were explaining.
Yeah, that happened with the site. So was it site mission? No, it wasn't that. It was the
DART mission.
The DART mission. Having that to the DART
You're
mission.
really mixing in the right circles. Clearly.
I know. Yeah. Yeah.
If you want to get me an invite to the next meal, then
Well, but I'm making a fool of myself in these
telling
scenarios.
people facts.
I couldn't
about
believe
stuff
that
they
though.
discovered.
This idea that a mega flood could form the English Channel, and I was just happened to be on the table with the person that
That's insane. I didn't
helped
know that.
discover it. It was absolutely
It's incredible. I mean, there's also evidence of this happening elsewhere on Earth. There's this whole region in Washington and sort of the northern USA called the Channeled Scablands.
What a name.
Which is very ominous sounding. But it is kind of, if you imagine draining the English Channel, what it would look like if it were completely dry.
Wow.
And this is one of what I think is one of the most fun geological conspiracy theories. Now, it's quite problematic and there's a lot of evidence against it.
Right.
So this is not fact at all. But some people in the past have hypothesized that this was due to an impactor from space hitting the, is it pronounced the Laurentide ice
Right.
sheet, which was on top of North America at the time, melted this ice sheet due to the huge increase in
shockwave,
temperature, the shockwave
yeah.
as a result of this impact, and caused these channeled scablands, sent mega floods going through this area of North America.
Wow.
It's not true.
very little evidence, but
Interesting,
It's a
then.
nice theory.
I enjoy the picture.
It's
yeah.
fun.
Yeah. Yeah.
Yeah. So, what are the specific hazards then associated with rivers? So, we've established flooding.
Flooding is really the big one, especially today and in the near future. When you think about the increasing storminess as a result of climate change, more floods are going to impact more communities, right? And this is just thinking about water that bursts the banks of the rivers and affects the communities living on the banks. Sediment is another really important thing that we need to think about when we're thinking about flooding and the impacts of climate change. Some of the research that I'm doing for my PhD is thinking about how these same processes that cause big floods affect source to sink processes. So what happens to the sediment, right? And the answer is, if you increase the amount of water that needs to go through a system in a given time period, say a year, you also, by necessity, increase the amount of sediment. What that means is you need to increase the amount of erosion that happens in the mountains. You need to increase the amount of deposition that happens at the delta or in the basin. And you've got these sort of sediment plugs, basically, that happen in rivers where you have so much sediment trying to be pushed down a river that it sort of gets stuck, and it causes more and more flooding in a sort of mini positive feedback. This is happening in the Yellow River in China at the moment. And when you have too much sediment exit the river channel and end up on the floodplain, a little bit of sediment is good for the fertility of the landscape. Too much sediment can destroy crops and agriculture over huge areas. So that's a massive issue. And talking about increasing rates of erosion in the hills, in the hinterland, that is also correlated with more landslides. So more erosion equals more landslides, more extreme events from source to sink as a result of climate change.
So does that then tie into your PhD and what you've done with your masters and stuff like that?
Yeah, it does actually. So, well, it's quite closely linked with my PhD topic at the moment. But I guess I got into this field during my master's project, which I did a couple of years ago at Imperial, thinking about ways to identify flooding in the rock record, so in ancient stratigraphy. And this is a an active challenge in earth science at the moment. It's easy to look at the rock record and identify long-term signals of flow variability. So flow variability being can we see from geology periods of high flow, periods of low flow. The difference between the extremes is flow variability. But can we identify it on a short timescale, on a kind of daily timescale that we expect to see flooding that we see around the world today, right?
Wow. So
on a kind of daily
high
basis.
resolution in terms of time
Yeah.
scales.
So this is the challenge, right? So this project that I did was studying the Pennant Sandstone Formation in South Wales from the Carboniferous. It's about 300 million years old. And it's this big sandstone formation which was formed by rivers. When Wales was on the equator, it was a jungle, it was a tropical rainforest full of weird and wonderful kinds of plants and trees that are now extinct.
Having just been in Wales, that's quite hard to imagine.
Well, it's wet enough still to sustain a tropical rainforest. And these sandstones are full of what are called cross sets. So cross sets are the remnants of dunes in ancient rivers. Sand dunes at the bottom of these rivers that are being pushed downstream.
These are like you look at a rock face and it's like zigzags on a rock face.
Exactly.
Right?
Yeah, lots of sort of slanting lines that cross cut each other. This is what they call cross sets. We can look at the shapes and sizes of these cross sets as well as a bunch of other things to measure in these sandstone deposits that can tell us everything we could possibly want to know about how these rivers behaved back in the day. How big they were, how fast they flowed, which direction they were going. Imbrication is one example. Now, the point of this research project that I've done recently is, as I've said, to see if we can identify flooding. And we can use the shapes of these cross sets to see whether or not the flow was in equilibrium with the sediment that was moving along the bed of the river. In simple terms, all that means is, did the flow of water last long enough that the sediment could catch up and move down the river in equilibrium together?
Okay.
If not, that affects the shape of the dune, it affects the shape of the cross set, and we can see that flow event was rapid, it was flashy, like a flashy flood.
And the dune itself in the rock record, would it look, well, would there be this perfect preservation of a dune? Would it be messed up? Or would the grain sizes be different? How would it be?
Well,
affected?
you don't see the whole dune. What you do see is a sort of lens, a sort of lozenge shape, like if you cut a minstrel in half and looked at it from the
So
side.
much product placement going on in this episode.
So it would look a little bit like that with these kind of diagonal lines going through it. And it's all made of sandstone. These are sand grains that are like a millimetre in size, roughly. The shape of this cross set, which is the sort of what's left over of the dune. The top 2/3 of the dune are sort of cut off by the next dune that comes along. Mm-hmm. It's eroded away, and you're left with the bottom third, which is preserved as a cross set. And what we found in Wales is that this whole formation, representing about 4 million years of stratigraphy, of geologic time, is dominated by signals of flooding.
Wow.
Based on this new method, right? Mm-hmm. But this is quite experimental, this approach. So we wanted another way, a sort of independent line of evidence to assess whether this was true or not. Can it be that this whole formation is dominated by flooding? Doesn't make sense thinking about it. But going around Wales, scrambling through the vegetation, we did find lots of independent evidence of flooding 300 million years ago. Wow. Namely, loads of woody debris.
Okay.
So log jams preserved in sandstone, which is, I find, super, super cool. So these are sort of petrified wood, preserved as fossils of these ancient extinct trees that have been torn up from their roots, or branches that have been picked up from the floor of these ancient carboniferous forests, dumped in the river, and caused the logjam. So we see those preserved in the sandstone in Wales. Not only that, but where we see more woody debris, we see the shapes of the dunes change even more.
Wow.
So not only do we have these cross sets preserving signals of flooding throughout the formation, but where they occur in close proximity to woody debris, the shapes change even more, and we preserve an even stronger signal of ancient floods.
Because you've got both those evidence and they're interacting.
Exactly. So this proves that this method really does work. That cross sets and independent facies-based evidence of flooding. So less about numbers and more about observables, more qualitative evidence in the rock record. These two things working together show that this approach really does work. And this is now published
can we read about it?
You can read about it. It's called Quantitative Constraints on Flood Variability in the Rock Record. And it does what it says on the tin, right? It's published in Nature Communications.
Awesome.
Go and read it. There's lots of pretty pictures of log jams.
So your first author on this?
Yeah.
Amazing.
Jonah's paper's out. Will you be touring this paper?
So far, it's only reached the departmental conference.
Watch this space.
Watch this space, yeah.
That is amazing.
But I guess there are a lot of, modern analogues for these wood jams and these petrified, well, not petrified yet, but there are a lot of areas currently where we can see this idea that these woods have been ripped up and then sort of deposited in these sort of lake environments or these in dunes. Is there any modern analogues that we can use? Or
we see this all the time. I don't know if I can think of a specific example, but rivers around the world, rivers that happen in densely vegetated areas, log jams are a thing that happen today all the time during floods.
It's probably worth pointing out that petrified wood is one of those remarkable phenomena that happen in geology, where this wood that is 300 million years old is preserved so well, and that's because it gets buried rapidly or in say sediment or in the presence of water. But because it gets buried so quickly, it gets subjected to a very reducing environment, which means there's very low oxygen. It means that microorganisms can't sort of feast on the wood and make it decay. Exactly, and that's how it gets preserved so well. And then over time, this water that's present might travel through the sediment, interact with the wood or react with it, and precipitate out minerals such as, say, quartz or opal, which slowly turns the wood into stone. And that's the idea of petrified wood, and I guess we can see that in the rock record, and we can see that in these dunes that Jonah was talking about.
Yeah, and the really high quality of preservation of this, I mean, as you're saying, of all of this wood in the pennant formation, really speaks to how rapidly they were buried. And rapid sedimentation, rapid burial happens in floods.
That is
Amazing.
awesome. So interesting.
We should probably talk. We haven't talked much about modern day rivers, but we could probably talk a little bit about something like the Nile, which is the longest river in the world.
Is it? How long is it?
Looking at it now, it's 6,650 kilometres, which is about the radius of Earth.
That is so long.
Wow.
I think there's a lot of chat about the source of the River Nile. Wasn't there like this famous, like no one knows who the source is? Did anyone hear about that? Top Gear did a whole episode on trying to find the source of the River Nile.
I did watch that. I was wondering about its scientific veracity.
Yeah, I think it's nonsense because I think it's well established what the source is. I think because there's a lake. Well, I'm trying to look at because the two major tributaries for the River Nile is the White Nile and the Blue Nile, both of which the source has been discovered. The source of the Blue Nile is in Lake Tanane in the Ethiopian highlands, and the White Nile is sourced from Lake Victoria in Uganda.
Fair enough.
So I mean,
solved it.
So Top Gear, when they say, I think they just need an episode idea, and they just thought, we find the source of the
They
River Nile.
needed a funny concept.
Exactly, and actually it was nonsense.
So that's the longest river.
Yeah.
What about? Is there a shortest river?
The shortest river, and I've just looked this up actually, is apparently the Ombla River in
Okay.
Croatia.
Well, let's try and guess.
Any guesses? How long is the shortest river in the world?
I'm thinking that it'll be something like, I'm going to go 2 meters or 5 meters or something like that, because I think it's going to be the source of the river is just going to be up a tiny bit up a slope of a bank of a lake or something, or an ocean.
Yeah.
And it's going to be like, it'll start there,
Yeah.
and then it's there.
Yeah.
But it's about what defines a river then?
I was going to go source to mouth.
Yeah.
Is that right?
I don't know. Well, in this,
Right.
it's apparently 30 metres long. So it's massive compared to this 2 metre river.
Sorry, yeah. Maybe I was thinking more of a stream then.
Oh gosh, and then a
Or what's the difference? What's the difference?
Where do we cut it off?
Or a
so
trickle.
that's the shortest. And then we've also got river basins, right? Can you
Yeah,
quickly tell
so
us what a river basin is?
A river basin is, you can think about a big sort of shallow bowl, the size on a sort of landscape scale.
Mm-hmm.
So this is the area over which rain falls, flows downhill, and all ends up in the same river.
Okay.
So you could have rain 50 miles to the east, rain 50 miles to the northwest, and it all trickles down into the same trunk river channel, the same main river channel, and out of the same outlet, right? It's also like a sort of catchment, right? So it's a basin because it's a bowl shape essentially. The biggest river basin in the world is actually the Amazon, which is 6.3 million kilometers squared in size,
That is crazy.
which sounds big, and is big.
I thought you were going to be like, but actually,
It sounds
No,
big
no, but
because
actually
it
it's
is
massive.
really, really massive. It's a third the area of the continent of South America.
Wow.
So if you just point at 1/3 of South America and you rain on it,
That all ends up
that's
in the Amazon.
that's going out of the same outlet.
Wow.
The outlet, incidentally, is as long, or the outlet is as wide as the distance from London to Paris,
Wow.
which is huge. The Amazon River Basin is 1/25 the land area of Earth.
No way.
So it just goes to show like how much of a chokehold rivers have on global landscapes. The fact that 1/25 of the Earth and what that landscape looks like is completely governed by one river.
What a point to finish on, maybe.
we can finish on there if you'd like to. Oh, one point is the deepest river. We haven't covered the deepest river.
Oh yeah.
Congo.
Congo.
Any guesses on the depth?
50 meters. Is
Um,
that huge? I don't really.
No, that's a good guess. It's up to 220 metres deep, which
Oh,
is
wow.
basically taller than St Paul's Cathedral and 2.5 times bigger than Big Ben.
That is really, really deep.
That's
50
so
metres
deep.
is really deep for a river. The Thames is 20 metres deep.
Is it?
220 metres
That is
for a river.
insane.
And think about the amount of water that is moving through that.
Yeah.
It's probably kilometres wide.
Yeah.
220 meters deep.
Wow.
There aren't many trolleys in the Congo, but
Yeah, if to all our listeners, please text us, message us on social media.
Oh, plug. Shall we say that our Instagram handle is @CoPod, COE pod, and on Twitter it's @TheCoPod, which is THECOE pod.
But please get in touch. Let us know anything you found in rivers, what you think the most likely thing to be found in a river. Maybe we can give you a shout out in our next episode. We'd love to hear from you.
Absolutely. All that's left to say is, Jonah, thank you so much for coming in, and it's been absolutely a pleasure and really interesting.
Thank you so much for having me. It's been an honour.
Thanks very much. Everyone, have a lovely week. Bye.
See ya.